Assalamu alaikum friends, my name is Bilal Khan and this is my 22nd video of DevOps. So in this video I am going to talk about the Kubernetes architecture. So in the previous video I have shown you what is the Kubernetes architecture somehow, but in this video I am going to briefly explain what is the Kubernetes architecture. Alright, so here is a cluster. Alright, so inside this cluster there are multiple nodes. Alright, so the first one is going to be the master node or the control plane, and the second one is the worker node. Alright, so you need to remember that the cluster has three types. So the first type, in which one master node will be having one worker node. Alright, in the second type there will be one master node and multiple worker nodes like in this one, and the third part in which multiple master nodes will be having multiple worker nodes. Alright, so inside this master node there are four components: control manager, etcd cluster, API server, and the kube scheduler. And inside the worker nodes there are multiple components like kube proxy, kubelet, container region, and the port. Alright, so similarly in the worker node 2 there are multiple components, the same multiple components like kube proxy, kubelet, container region, and ports. Alright, so after that the next part is the kubectl. So what is kubectl? So kubectl is the front page through which you can interact with the master node. Alright, so basically the master node will manage all the worker nodes. Alright, so but if you want to communicate with this master node, you will have to use the kubectl. Just like we have seen in the Docker video that you will have to write the docker run that command, docker run that command. So similarly you will have to use the kubectl run that command, kubectl and stop that command. So with the help of kubectl you can interact with the Kubernetes. And the first thing you need to remember is the API server. Alright, so the API server is the most important thing if you want to build the connection between the master node and the worker node. As you can see that these are all the components of the worker node and the master node that are communicating with each other with the help of this API server. Alright, so the kubelet is communicating with API server, kube proxy similarly with this kube proxy and kubelet is communicating with each other, and the API server is also communicating with control manager and kube scheduler and etcd cluster. Alright, so basically the API server is the front page through which you can interact with the worker node and the master node. So now the thing you need to remember after the API server is that there is a control manager. So the control manager will basically make the actual state equal to the desired state. So let's take an example that I want to create 4 containers. Alright, so this is my desired state that I want to create 4 containers. But the control manager, but basically the worker node has created 3 containers for me. So in this way, the control manager will check that here is the 4 containers demand, but only the 3 containers are created for it. So the actual state is not equal to the desired state. So it will not accept the data. Alright, so it will make sure to make the actual state equal to the desired state and only provide the required containers that are requested. Alright, so the next part is the kube scheduler. Alright, so before discussing this kube scheduler, let's move to the etcd cluster. So basically the etcd cluster contains all the information that the control manager wants. Alright, so the control manager will, the data that will be provided of the containers will be provided from the etcd cluster to the control manager. Alright, so the control manager does not know where the data comes from, where the desired state data comes from, or where the actual data state data comes from. So basically the etcd cluster will provide those information to the control manager. So this is basically working as a database. Alright, so you can communicate with this etcd cluster with the help of API server. Alright, so this API server will basically contain all the information, and after that the etcd cluster will communicate back to the API server, and the API server will provide the information to the control manager that this is the actual state or this is the desired state. So with the help of etcd cluster, the control manager can know the information. So the etcd cluster stores the information in the form of key value pair. Alright, so first the key will be given and then the value will be provided. Alright, so let's say there is a key name and the value would be Bilal. Alright, so after that the control manager will not perform the functionality to make the actual state equal to the desired state. It will basically perform an if-else statement. Alright, so it will only work on the if-else statement, that whether the actual state is equal to the desired state or not. So it will not perform that functionality to actually make them equal. Alright, so what is the component that is basically performing that functionality? The functionality that will be performed will be called kube scheduler. So the kube scheduler will basically perform the functionality to make the actual state equal to the desired state. Alright, so this is the actionable component of the master node. Alright, so that will perform the action of it. So these are the components that are basically watching the data to be equal to the actual or the desired state, but the kube scheduler will make that happen. So now let's move to the worker node. So here you can see that the worker nodes, there are multiple components like kubeproxy, kubelet, container engine, pod. Alright, but you need to remember that the kubelet is the important part of the worker node. Why? Because this kubelet is connected to all the pods like port A, port B, port C, port D, port E. Alright, so on the worker node side, there is also an agent required that will provide an information to us. Alright, so what is happening to this in this worker node should be provided to this master node. Alright, so this kubelet will basically provide that information, that how many containers are present in the pod, or how many pods are present in this node. Alright, so these are the information that will be provided to the API server. Or as you can see that the kubelet is connected to the API server, and after that the information will go to the etcd cluster, and this etcd cluster will basically store that information that the kubelet has provided. So this is an agent that is basically working on another side of the node. Alright, so now let's move to the kubeproxy. So the kubeproxy will basically handle all the networking stuff, like which IP address to provide to which node. Alright, so how to make the connections between each node. Alright, so this is the functionality of the kubeproxy. And another part is the container engine. So container engine will basically pull the image, run the image, create the containers, alright, create the images from the container. So this is the functionality of the container engine. So there are multiple container engines like Docker, Containerd, Rocket. So basically Kubernetes has created a separate space for it in which multiple containers can be added. So this similar space, common space is the container engine. Alright, so the next thing is the pod. So the pod is the smallest unit of the Kubernetes. So it is the smallest unit of the Kubernetes in which multiple containers can be added, or one container can also be added. So basically there are multiple type of containers, like the Docker has a separate kind of containers. Similarly, that Containerd has a separate kind of containers. So these type of containers has different settings. So in this way, the Kubernetes has created a common space in which, and that space is called pod. Alright, so in this pod, there are multiple kind of containers can be added. Alright, so this is the functionality of the pod. So now the next thing is going to be the, as you can see that the container engine is connected to the containers. Alright, so all the containers will be given to this pod with the help of the container engine. So these are the arrow keys that are showing here. So now the next thing is going to be Linux and hardware. So the master or the node or the control plane is running inside the Linux, and the Linux is running inside the hardware. Alright, so now let's move to the definition of each of the things, each of the components that we have discussed it here. Alright, so roles of the master node. So it manages the health of the cluster, alright, like creating or deleting the pods, etc. So it will basically manage the health of the cluster. So Kubernetes cluster contains containers running in bare metal, VM instances, cloud instances, or mix. Alright, So the containers that will be running will be either in bare metal or hardware, or VM instances in virtual machines, or cloud instances, alright, so like AWS, Google Cloud, Azure, alright, or mix. So some of the containers may run in virtual machines, or some of the containers may run in the cloud instances. Just like in the previous video, we have discussed what is the hybrid cloud. So Kubernetes designates one or more of these as master and all others as workers. So basically there will be multiple nodes present inside the Kubernetes. So the Kubernetes will basically designate some of the nodes as master node, and Kubernetes will also give the designation to all the other nodes as the worker node. Alright. So cluster is a group of nodes. So the nodes is the collection of nodes is called the cluster. So a cluster contains at least one master node and one worker node. So the minimum requirement for the cluster is to be having one master node and one worker node. So the master is now going to run set of K8 processes. Alright. So the master will run different kind of processes of the Kubernetes, and these processes will ensure smooth functioning of cluster. Alright. And these processes are called control plane. So you can create multiple masters for high availability. So you can create multiple masters. So if one master is down, then another master is present that will perform the functionality. So control plane manages the worker node. Alright. So this is the thing that we have seen in the previous slide. So pod runs on the node. Alright. So node is controlled by the master. Alright. So some of the components of the master node or the control plane, the first component is the API server. So the API server communicates directly with the user. So you can create with you can write YAML or JSON file, or write commands in the kubectl to communicate with it. Alright. So you can either write the commands in kubectl, or you can write the commands inside these files that will basically run, and it will transfer the data with the help of API server. So it is used to send and receive the request inside the master node. Alright. So it will basically communicate inside the master node, and it will also communicate to other worker nodes also. Alright. So it only builds the connection and does not provide the solution. So the API will build the communication, but it will not provide the solution. So now the next part is going to check the data that is given to it. So the control manager will basically make a balance by contacting the etcd cluster that what actually happened, means what is the desired state, and what should happen, that what is the actual state. So let's say a person wants 4 containers. Alright. So the desired state is the 4 containers, and is only given 3 containers. So the actual state is the 3 containers. So these containers are mismatched because 4 containers are required and 3 containers are given. So in this way the containers are mismatched, so the control manager won't accept it. Alright. So this will basically work as an if statement, that whether the actual state is equal to the desired state or not. If it is not equal, then it will not accept it. If it is equal, then it will accept it and give the further execution to the kube scheduler. But before discussing what is kube scheduler, let's discuss the etcd cluster. Alright. So basically the etcd cluster is a kind of database that contains all the information, like how many containers are present there, or what are the IP addresses, etc. of the cluster. So it will contain all the information of the cluster. So the control manager knows that the status of with the help of etcd cluster. Alright. So the control manager does not have information. It will get the information from the etcd cluster, and according to that information it will check that whether the actual state is equal to the desired state. From an etcd cluster, the actual state and the desired state's data will be given to the control manager. Alright. So now with the help of that etcd cluster data, the states of the data will be given to the control manager. So that's how the control manager will know that what are the states of the etcd, or what are the states of the data. and etcd cluster is not directly a part of the Kubernetes. This is the part, this is the thing that you need to keep in mind, that although the etcd cluster is not a part of the Kubernetes, but it is required for it. So API server can only access the etcd cluster. Alright, so if you want to access the information, if the control manager wants to access the information, or the kube scheduler wants to access the information, so it will first contact the API server, and from the API server the request will go to the etcd cluster, and the etcd cluster will give back the information to the API server, and from that API server the information will be given to the control manager. Alright. So the etcd cluster stores metadata. What does it mean by metadata? So metadata is the data of data. Alright. So let's say I have a picture. Alright. So the picture is a type of data, but that picture is not identified by the computer. Why? Because picture is just an image. Alright. So picture contains some kind of data, like what are the pixels, how many pixels, what is the size of that picture. Alright. So these are the data of that picture. Alright. So the data of data means the picture has some kind of data also, that will be called the metadata. So the etcd cluster stores the metadata and the status of the cluster. So the entire state of etcd cluster is available on every node. Alright. So the kube scheduler. Now the important part of this is the kube scheduler. So kube scheduler will basically perform an actual task that the controller has requested to it. Alright, so it will basically perform an actual task. So it does not care what are these tasks. Alright, so to care what are these tasks, basically the control manager is present. It will check that whether the actual state or the desired state is equal, but the kube scheduler is only going to perform the tasks. Alright. So kube scheduler handles pod creation. It will create the pods, and after that, if the pod is created, then the pod will be given to the kube scheduler, and the kube scheduler now will match the pod that whether the actual state or the desired state is equal. But it will create the pod creation, and after that it will manage those pods, and then the control manager will check whether the actual state is equal to the desired state. All right. So the scheduler watches for the newly created pods, alright, for that have no node assigned to it. Alright, so basically the scheduler is smart enough to basically create the pods and assign those pods to the empty nodes. So let's say there are some nodes working, alright, and there are some nodes that are not working and that are free. So the scheduler is smart enough to create the pods, and those pods should be given to the free nodes, so that the free nodes is also going to work. So it is responsible for finding the best node for that pod to run on. Alright. So now let's move to the declarative or imperative way to interact with Kubernetes. So for interaction, the commands can either be written in kubectl command line tune, alright, called imperative way. So you can write either commands in kubectl in the form of commands, or you can write the commands in YAML or JSON file that is called the manifest file. Alright, and that file is called, and that commands that are written in the files will be called declarative way. Alright, so you will have to either write the commands in kubectl one by one, or you can write the commands in JSON or YAML file that will be executed as once. Alright. And this file will be executed with kubectl apply f file name. Alright, so the request will go to the API server. Alright, so whether you write the commands in kubectl or you write the commands in YAML, so this request will be go to the API server, and from there it will go to the control manager, and the control manager will send it to the scheduler. So now let's discuss the components of the worker nodes. We have discussed the components of the master node. Now let's move to the worker nodes. So the first component is that the kubelet. So kubelet is an agent running on every worker node, alright, that talks to the API server. So it will basically work on every worker node, and that kubelet will talks to the API server. It controls the pod and sends the pod creation request to the node. Alright, so let's say a pod is demanding some containers to be created, or a worker node is demanding to be some pods to be created. So it will send those pod requests to the master node with the help of API server. Alright, so now let's move to the container engine. So container engine will contain the Docker container, container D, Rocket. So there are multiple kind of container engines that are present here. Alright, so it works with kubelet. Container engine works with kubelet. It pulls the images, creates the containers, run those containers, and run the images on the containers. It starts and stops the containers and asks you which port number to open and communicate with it. All right. So the next component is the queue proxy. It will handle the networking part. So it will basically assign the IP address of the pod. All right. Containers do not have an IP address. You need to remember that the containers do not have an IP address. Instead, the pod will be given an IP address. So the queue proxy runs on each node. All right. And this makes sure that each pod will get its own unique IP address. All right. So two pods are not connected with each other directly. Alright, so two pods are not connected with each other directly. Instead, the pod will give a message to the queue proxy, alright, and that queue proxy will deliver that message to another pod. Alright, so now the next part is the pod. So the pod is the smallest unit of Kubernetes. So inside pod you can add containers. The reason for creating the pod is because there are multiple type of containers and they have different settings. So pod is a common space in which any type of containers can be added. In Kubernetes, the control unit is the pod, not the containers. So the thing that will control is basically the pod, not the containers. So pod may contain multiple containers, but usually it contains one container. Why? Because multiple containers are tightly coupled. Alright, so they are tightly coupled. So if one container is failed, then other containers will also fail. As a result, a new pod will be created with a new IP address. So in this way, if one container is failed, then other containers will also fail. So the pod will not be prepared. Instead, the new pod will be created. Alright. So some of the steps. So first of all, create a microservice, then containerize this microservice, make the containers of it, and then put the containers in pods. All right, and after that, deploy those pods to the IPv server, all right, API server, and then the API server will send the data to the control manager, and the control manager will take the information from the etcd cluster, all right, or from the API server to check the states. Alright, and if the actual state and the desired state is equal, then it will be transferred to the queue scheduler, and the queue scheduler will assign ports to the nodes. Then it will again contact the etcd cluster to update the data there. Alright, because now the data, actual data and the desired data is equal, so it will contact the etcd cluster again, so that the data should be updated there. Alright. Now let's move to the multi-containers pod. So the multi-containers inside a pod share their memory. Or multiple containers inside a pod share their memory. Although the pod is providing an IP address, but multiple containers inside the pod are connected using localhost. Alright. So if multiple containers are present inside the pod, they will be connected with the help of using localhost. So either the required number of containers will run or not. Alright, so this is the thing that you need to keep in mind, that if one container is failed, then all the containers will fail. Alright, so in this way, if one container is running, then all the containers will be running. Alright, so in this way, if one container is failed and all the containers are failed, after that, the new pod will be created. It will not be prepared. That pod that is failed will not be prepared. Instead, it will be created again with the unique IP address. So if the containers did not run, then a new pod will be created again with a new IP address. So pod has the limitations that you cannot perform auto-scaling and auto-healing versioning rollback by default. Alright, so this is the limitation that the pod has. So if you want to remove this limitation, you will have to install the plugins for it. All right. So you have to install the plugins manually to make get out of this limitation. So these are some of the plugins or the higher level Kubernetes objects. All right. So replication set, it will basically perform the auto scaling or the auto healing. So if you want to know what is auto scaling, auto healing, you have to check my previous video. So deployment, it is also a plugin or the higher level Kubernetes object that will basically perform the versioning and rollback to transform from one version to another version. All right. So the service. So service is a higher level Kubernetes object that will basically assign the static IP address, because the pod has a dynamic IP address that will be created every time. All right. So if you want to assign the specific static IP address, you will install the service for it. All right. After that, the next one is the volume. So volume is basically storage outside the node. So it is also a storage outside the node that will basically work as a backup. So if the main storage is deleted, this volume will store that data, and this volume data will be used again. All right. So what we have learned, but before this slide, let's close this and let's write the kubectl, and after that you will find that this is the Kubernetes website, and install tools, click on this. Now you can see that there are some tools that are provided here. kubectl, if you want to install, you can install it on Linux, Mac OS or Windows. So I'm using Linux. Let's click on this. As you can see that it is providing me three options, like to install it with curl or native package management or other package management. So I will click on this in other package management. So these are all the commands that you can run, but I'm using the snap command for it. Why? Because the snap is a store that will basically by running only this command, it will install the kubectl for me. But if you want to install it by using other native package management or curl command, you can use it. All right. So let's go back again, and now these are some of other packages that I'm not going to install, but this is the Minikube that you need to install, because it will provide you one master node and one worker node to practice for free. All right. So let's click on this. As you can see that the Minikube start is open, and it is requiring us to have 2 CPUs, 2 GB of free memory, 20 GB of free disk space, internet connection, and virtual machine manager or container. All right. So these are the operating system and they have multiple commands for it. So for Mac OS they have different commands, for Windows they have different commands. I'm using Linux. Alright, so this is the architecture, release type or installer type. You can click any one of them. So let's copy this command, and after copying it, you will paste it in the terminal, and if you paste it and run it, it will run the Minikube for you. But you need to remember that it will take some time and it will take some space also. So if you have 2 CPUs, 2 GB free memory, 2 GB hard disk free, then it will install for you. So now let's move to the terminal and write kubectl. I have installed it previously. So these are the commands that are required that you can use for the kubectl to run or to set, create, etc. So now let's move to another command, that is Minikube. So if I click start, Minikube start, it will start for me. But it will take some time. So I will close it. Let's clear it. And now again Minikube stop. It will stop the Minikube for me. Sorry. So it is now going to stop it for here. Alright. So this will basically contain one node. In one node there are multiple, there are one master node and one worker node. So this is a one cluster. Alright. So you can use the Minikube for practice. You can also use the cloud version like AWS or the Google Cloud or Azure, but I'm not going to discuss it here. But if you have money, you can sign up for that cloud providing service, but it will give you some time for it to use it for free, but after expiration you will have to pay for it. But for practice I would recommend to use the Minikube. If you want to make mistake in it in your computer, so you can make it here. So now let's move to the slide again. And what we have learned, the first thing is the roles of the control plane or the master. Components of master, components of worker node, higher level Kubernetes objects or the tools. That's it. I hope you like this video. So if you like this, then make sure to subscribe to my channel, and if you have any questions, then ask those questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.